Hello, my name is Leo. Today we're going to talk about complex motions. So first, what does a complex motion consist of? It consists of more simple motions. As its name says, it's complex. And these simple motions happen at and for the same time, meaning that they happen simultaneously and have the same duration. Some special cases of complex motions are motion vertical and horizontal. Vertical can be down or up. First is vertical motion down, where body's motion is at angle alpha of minus 90 degrees. So minus is down from horizontal direction and plus is up from the horizontal, and 90 degrees because it's vertical. So minus 90 degrees. And velocity of body is actually velocity of body in y-axis direction. If we imagine body put into two-dimensional x-y coordinate system, some body as a geometrical shape. So v is equal to vy, which is sum of that starting velocity plus the product of g times t, so of acceleration times time, and this g is acceleration of planet's g-force, so gravitation force. And we have also formula for distance, which is also in y-axis direction. And finally, free fall is a special case of vertical motion down, when body falls by itself, so it doesn't have initial force that acts on it, so it doesn't have zero time velocity, this starting velocity is equal to 0 meters per second. And now we have vertical motion up. In this kind of motion, alpha is plus 90 degrees, and velocity is v0 minus g times t. We could see that this formula is very similar to the previous one, so to the formula of vertical motion down, but here is minus and there was plus, because here the body slows down as it goes up, and in vertical motion down, the body was speeding up while going down. So here slows down, then it's minus. And now we have y max, which is maximal height the body comes to. So the highest point in the body's motion up. And t max is time for which the body makes that motion, which is actually proportion of starting velocity divided by g. And on this picture we have body which starts at the initial height of 3 meters with some starting zero velocity v0 and comes to the highest point of 9 meters, where its velocity comes to 0 meters per second because it stops at that highest point, and then it comes into free fall down. After that vertical motion up, it goes down into free fall. And now we have horizontal motion, where angle is 0 degrees because it is in the horizontal direction. And the x-axis component of velocity is always the same, and it's equal to the 0 velocity the body is thrown at the starting point. And the y-axis direction is product of g times t, so of acceleration and time, so it changes. And from the right-angled triangle we could see these relations, such as that tangents alpha is v in y direction divided by velocity in x direction, and after Pythagorean theorem we get this one formula, the third one, and the last two are y and x, which are distance of body from the starting point in y-axis and x-axis direction. And on this picture we can see body with the initial height of 9 meters and with the initial velocity of v0, which comes down to the finishing point down right. And now generally curved line motions. Body can be thrown at any angle up. It doesn't have to be 90, neither 90 nor 0 degrees. So it doesn't have to be neither vertical nor horizontal motion. It can be at any other angle also. And curved line motions are generally a combination of linear motion, which is motion at horizontal direction, and free fall, which is fall down, so is in vertical direction. And acceleration in every case is equal to g, so that acceleration of planet's g force, of planet's gravitation force, and for Earth, g is about approximately 9.81 meters per second squared. And from right-angled triangle, we can see the relations of sinus alpha and cosinus alpha, and from them derive the formulas for Vx and Vy, which are velocity of the body in x and y-axis direction, and also can put that into a formula after Pythagorean theorem, which is this one, right? And the last two formulas, x and y, refer to the, as I've already said in the horizontal motion, to the distance of the body in x and y-axis direction from the starting point, which are actually product of velocity and time, which is distance. And just to say that velocity at any point given as a vector is always a sum of the velocity in x direction and y direction. Thanks for watching. I hope you've enjoyed this video and that you've learned what are complex motions. And stay with us.